Hello my dears, I hope you are fine. We are beginning the first video for the e-learning in the chemistry with the chapter 14, section 1, the properties of acids and bases. In this video we're gonna talk about the properties of acids and bases and the how to name the acids and the industrial application of the acids. In the other video we will continue the rest of this section. Firstly, when we talk about the properties of acids, we will find that the aqueous solution of acids have a sour taste. Usually we do not depend on this property for assessing this substance is an acid or not, because most of acids are poisonous or having a corrosive, which meaning that they can burn our soft tissues. But if we taste some of this, like the acetic acid, which is the home vinegar, which is a diluted acetic acid we use in our daily foods, you will have a sour taste. The second property is the acids change the color of acid-base indicators. Some indicators used to differentiate between acids and bases. One of them is the pH paper, which is turned red when we immerse it in a acid solution. The third property is some acids react with active metals and release hydrogen gas H2. According to this equation, barium as a solid, when it reacts with H2SO4, which is a strong acid, it will yield PaSO4 and H2 gas. We can see this hydrogen gas released here, and we can see this solid, which is barium sulfate. The fourth property is acids react with bases to produce salts and water, and acids conduct electric current. When we turn to the properties of bases, we will find that the aqueous solutions of bases, unlike the acids, have a bitter taste. But again, we do not rely on this property to assess if this is a base or not, because the bases also have a corrosive action on our soft tissues and skin. The second property is the bases change the color of acid-base indicators, but in this time when we use a pH paper, it turns the color of pH paper into blue instead of red in the case of acids. The third property is the dilute aqueous solution of bases feel slippery, like the soup. When you are washing your hands, you can feel the slippery feeling of the soup. This is similar to what we feel when we deal with some bases. And the fourth property is the bases react with acids to produce salts and water. And when we are talk about the last property, is the bases conduct electric current. To see what we are talking about in the reaction between acids and bases to release salts, we will see this simple equation like this. when we talk about the reaction between H2SO4 plus NaOH as a base, it will give, we will make a double displacement reaction like we learned in the previous chapter. So we will have Na2SO4. This is due to the valence of the sodium and the sulfate ion, so we will need to add 2 here to balance the equation, and this also will give us 2. We will take H from here and OH, which will be added together to form the water. So the equation here is giving us a salt, Na2SO4, which is a sodium sulfate salt, and water, 2 molecules of water as here due to the balanced equation. This is when we talk about the double displacement reaction, which happen when the acid and base react together. And when we are talking about the third point, what we will talk about, which is about the acids nomenclature, or how to give names to an acid. The acids have 2 types. A binary acid, which is an acid that contains only 2 different elements, hydrogen and one of element which are electronegative. For example, when we are talking about the HF, hydrogen fluoride, HCl, hydrogen chloride, hydrogen bromide, or hydrogen iodide. When we are talking about how to change the name to an acid, we take the name of a binary acid begin with the prefix hydro. Okay, so then we have the root of the name of the second element, like when we are talking about fluoride, so we will talk about the root of the name, which is fluor, so we will have hydrofluor, and then the name ends with the suffix ec. So the name of the acid, which is the normal name is hydrogen fluoride, will turn to hydrofluoric acid. Hydrofluoric acid. The same will be with HCl, which is hydrogen chloride, will turn to hydrochloric acid. HPR, hydrochronic acid, HI, hydroiodic acid, and H2S, hydrosulfuric acid. This is about the first type or the first category of the acids, which is the binary acids. When we are talking about the second type, which is the oxyacids. Oxyacids are a part of ternary acids, which are made of 3 elements. The 3 elements are hydrogen, oxygen, and a third element, but it usually a non-metal element. For example, we will talk about the HNO3 and H2SO4. The name of the oxyacid follow a pattern. Okay, we will follow some rules to give the names. The name of their anions are based on the names of the acids. Let's see an example to imagine what we are talking about. The anion forming this acid is called acetate, CH3COO. This anion turns into an acid when we add H to it, so the acid become from the acetate anion, so it's like we have see here in the formula CH3COOH, so the acid name is acetic acid. And second example, H2CO3, which is carbonic acid. Why it's called carbonic acid? Because it's formed from the carbonate anion. The same for iodic acid, and now we will have these four acids which will have a better difference between them regarding the number of oxygen atoms here in this anion. Here we have the anion called hypochlorite, which have chlorine and oxygen, so it's called hypochlorite anion, which give the acid hypochlorous acid. And when we are talk about the second anion regarding chlorine and oxygen, which have a chlorine and two oxygen atoms, it's called chlorite. Chlorite gives a chlorous acid. And when we are talk about the chlorate, it gives chloric acid, and ClO4, which is a perchlorate anion, it gives a perchloric acid. The same with the nitrous acid and nitric acid. It depends on the number of oxygen. If we have two oxygen atoms, we are having a nitrite anion, and when we have three oxygen atoms, we have a nitrite and nitrate. Nitrite gives a nitrous acid, and nitrate gives a nitric acid. And also the phosphorus acid and phosphoric acid. The difference also related to the number of oxygen atoms. Here is 3 oxygen atoms, and here is 4 oxygen atoms. Here it's a phosphite and phosphate. Phosphite gives a PO3 to -3 the valence, and we have a -3 valence also, but we have 4 oxygen atoms here, so it's a phosphate and it's a phosphite. Phosphite gives a phosphorus acid, and phosphate gives a phosphoric acid. The same with a sulfite and sulfate, sulfurous acid and sulfuric acid. Okay, when we are talking about the third topic, when we are talking about in this video, it's about the industrial usage or applications for some acids. We will have a brief summary on them. The sulfuric acid has the formula H2SO4. It's mainly used in oil refiners and to extract metals from ores. When we are having ores which are a rock having a lot of metals, we need to refine, we need to select some of them. For example, we need to extract the aluminum from an ore is called a bauxite having a lot of other metals, so we need to refine it, so we use in this industry the H2SO4 or the sulfuric acid. It's also used in automobile batteries. The car batteries we are usually dealing with need a sulfuric acid. Also, the sulfuric acid used to dehydrate means remove water from other compounds, so it used in some industries related to this or need this property, like the sugar making. So when we are talking about the second one, which is a nitric acid have a formula of HNO3. It's a volatile, unstable liquid, so we need to make an aqueous solution of it by dissolving it in water to be more stable. The nitric acid used with or in the industries of rubber, plastic, dyes, and fertilizers, and some drugs. It will stain the protein yellow, and so if we drop some of them on our skin, it will turn yellow, and it may have some burns. So when we deal with it, we need to be more cautious, and it may cause a suffocating odor. Suffocating odor means that we can't, or it worsen our breathing quality. The third one is a phosphoric acid, which have the formula of H3BO4. Phosphoric acid mainly used in making fertilizers and animal food, and it has a pleasant but sour taste, and it is not toxic. So it's used as a flavoring agent in some beverages like the carbonated water, Pepsi and Coca-Cola, and so on. And it also used as a cleaning agent for a dairy equipment. And when we are moved to the hydrochloric acid, which have the formula of HCl, it's used in a process called pickling of the iron and steel. Pickling meaning that when we need to clean the metal from the impurities, we will put it in a acid so we can remove surface impurities. And it also used to correct acidities in swimming pools and to clean masonry. When we reach to the final acid, which is the acetic acid, the acetic acid have the formula of CH3COOH. The acetic acid is a clear, colorless, and have a pungent smelling. It's known as a glacial acetic acid. Glacial means it's related to the ice or something like this. So we called it like this name, glacial acetic acid, because it has a very low freezing point, which is at 17 degrees Celsius, which means it will be getting freezed in the room temperature. We will use the acetic acid in a plastic industry and in some food supplements like the lysine, the essential amino acids, and it's used as a preservative to prevent the growth of molds and other fungi on the food. We use the acetic acid as a diluted form in the concentration of 4 to 8% as a white vinegar, which is used in our daily food. So we have finished what we need to know in this video, so let me ask you some questions, and I will give you a time to think about it, to check that you are understanding what we have studied in this video. Okay, when we ask about the properties of acids and bases, If an acid and base react together, what will they give to us? And give me an example. You will have a 15 seconds starting from now. Exactly, the answer is it will give a salt and water. You can choose any example of the acids and bases you are known. You may use the example I have explained with you in this video, and you can use any other example, but you need to make the double displacement reaction. Okay, when we are talking about the properties of acids, it reacts with metals to give you have a 15 seconds again. Don't forget the example. Okay. Okay, let's move to have another question, which is in your worksheet at page number 2. We need to name the following compounds as acids: H2SO4, H2SO3, H2S, HClO, and hydrogen cyanide. We will talk about this laterally, so we will just need to focus on A, B, C, D. Take care, is it an binary acid or an oxy acid? Okay, we will start with the first one, H2SO4. It's related to the sulfate anion, so it's sulfuric acid. So A is a sulfuric acid. Okay, let's move to B. It's related to a sulfide anion, so it's sulfurous acid. The first is sulfuric acid and the second is sulfurous acid. And now with C, H2S. Is it a binary acid or a oxy acid or ternary acid? It's a binary acid, so we follow the rule of hydro and the root name sulfuric acid, hydrosulfuric acid. And now with D, HClO4. Take care of the oxygen atoms number 4. So it's related to perchlorate anion, so it's a perchloric acid. Thank you for watching this video and hope you all understand these topics very well. See you in the next video.